Hello guys, welcome to my channel Live It Up Science. Today's lecture we are going to discuss about the resting potential and action potential. If you want my video on the structure of neuron as well as on the classification, then comment me in the comment box, otherwise I'll not upload that video. So we are start with the resting potential and action potential. So first question arises, what is resting potential? The resting potential is that when the nerve fiber is in the state of the rest, that is, the nerve fiber do not conduct any impulse from it. During the resting potential of the nerve fiber, the outside of the nerve fiber is positively charged with respect to that of the inside. That means the inside are the negative charge. The outside of the nerve fiber that contain more amount of sodium ions, whereas the inside contain more amount of potassium ions. So this difference of the positive and the negative, the potential difference of the positive with respect to the inside of the plasma membrane, this is known as potential difference. So at this stage, the plasma membrane is in the inactive state. That means the plasma membrane does not conduct any of the impulse. That is, no impulse is generating through the plasma membrane. So the amount of the plasma potential difference during the inactive state, during the resting potential, the amount of the resting potential, that is from minus 60 millivolt to minus 90 millivolt. And whereas the large axon of the squid, the resting potential of that axon, that's minus 60 millivolt. So now the question arises, how this resting potential is measured? There is an instrument that is used to measure the resting potential. How it is set up? For example, we take a cell, right? We take this cell having the axon and the exoplasm in it. We have to calculate its resting potential. So what we do, it's measured with the help of the two microelectrodes. The first microelectrode is attached with the external surface of this nerve fiber, and the second with the inside of the nerve fiber, and both the microelectrode are connected with the galvanometer. Now the reading on this galvanometer, like if the reading comes out in the negative, then the inside of the cell is negatively charged with respect to the outside. Now this negative and the positive charge, when this set up in the cell, so at this time the nerve fiber is said to be electrically polarized, right? So in some cells like these nerve cell and the muscle cell, the resting potential varies when the cell excites. So these cells are said to be excitable cells, whereas in the other living cells the resting potential remain constant. Resting potential remain constant. So that cells are said to be the non-excitable cells, right? So now we'll proceed towards the action potential. This is all about the resting potential. What's in the resting potential? The nerve fiber contain the outside of the nerve fiber is positively charged with respect to the inside, and the concentration of the sodium ion is more than the potassium ion. The sodium ion is concentrated more towards outside the cell than towards the inside. During this stage, the sodium potassium pump is going on. That that is, the sodium and the potassium ion are diffusing through this plasma membrane, and at this stage, at the resting potential, when the nerve fiber are not excited, at this stage the resting potential of this nerve fiber is minus 60 millivolt to minus 90 millivolt, that is, both are in negative. And the large squid, the axon of the resting potential of axon, large axon of the squid, that's minus 60 millivolt, and the resting potential is measured by using this instrument. This is microelectrode. This is connected outside the nerve fiber. This is outside microelectrode, and this is inside microelectrode. As this is connected with the inside of the nerve fiber, the reading, if the reading on the galvanometer is negative, then this suggests that inside of the this nerve fiber, that is negatively charged with respect to the outside, right? And the cells like nerve cells and muscle cell, their resting potential varies, and these are said to be excitable cells, whereas the other, in case of other living cells, the resting potential remain constant whether the cells excites or do not excite, then that their resting potential remain constant, and that are known as non-excitable cell. Now we'll proceed towards the action potential. The resting potential of the mammalian neuron that remain constant unless or until the stimulation is not provided to them. That is, unless or until the stimulation is not given, any kind of stimulation is not given to the cells, the neuron remains in its inactive state. So what happens when the nerve or the neuron that receives the electrical, the chemical or mechanical stimulation? What happen after that? Now when the neuron that receives the signal, or when the stimulation is provided to them, that means the axon now become excited, right? In the resting phase, these are the positive charged, and inside is the negatively charged. So what happen when the axon is excited? This is at the resting axon. So when the axon is excited, what happen in the excited axon? This is excited axon. So the starting portion that become depolarized. That means the inside become positively charged with respect to the outside, or we can say the outside become negatively charged with respect to the inside, and the other neuron remain in the inactive state. So when the inside of the neuron becomes positively charged with respect to the outside, then what happen in the resting stage? The sodium ion concentration outside the neuron is more as compared to inside, whereas inside the potassium ion concentration is more than as compared to the outside. And in this case, in the resting potential, the membrane is more permeable to the potassium ions. So here the sodium ion start going inside the nerve fiber, whereas the potassium start going outside the nerve fiber. So now in this case, the neuron is more permeable to the sodium ions and is less permeable to the potassium ion. So this part now become depolarized, and this is at the resting stage. So now the stimulus that transfer in the axon, right? So what happened after that? The third stage, what happened when this depolarized part that shifted, like here, it is depolarized part. So now what happened with this part? This again become repolarized. That means the polarization again, these part again get polarized, and this is known as repolarized. This is in the resting stage. So when it become repolarized, what happened? Now same case of the resting potential of the resting axon appears. That is, the outside is positively charged with respect to the inside. In the depolarized, the inside is positively charged with respect to outside, and in the resting, the outside is positively charged with respect to the inside. And in this way, the movement of action potential goes on, like the now the next part that became depolarized, this part became repolarized, and the further one is resting. Now after that, with the step, the complete axon, the complete neuron that become depolarized and repolarized, and in this way the action potential, the impulse goes on, right? So now the final question. The question is that, is exoplasm play a direct role in the conduction of nerve impulse? For this, to get an answer of this, the scientists have taken the axon having the exoplasm in it, right? So what they did after that, they replaced the exoplasm with the salt solution. They take the axon, replace the exoplasm with the salt solution. So what they saw? They saw the amazing behavior of the neuron, that the axon that contain the salt solution, that still conduct the impulse, that also conduct a several hundred to thousand of impulse. So this shows that the exoplasm play a no direct role in the conduction of impulse, rather the axon play a direct role in the conduction of the impulse. So guys, this is all about the resting potential and action potential. See you next time. Bye bye.